All right, welcome everyone. Today we're going to talk about functions. And to get started with spreadsheet functions, I like to give an analogy to build up from like the easiest possible way to kind of guide people into how functions work in a spreadsheet. Since most of you have done some coding already, this will be similar to the kinds of functions you see in code. They actually work pretty well in concert with each other. There are some syntactical differences that we'll talk about, but what I want to cover in this lecture is basic functionality of what functions actually do and what they mean. All right, so functions are essentially virtual machines. They do something. They take things in, they do something to them, and then they put things out. So in our analogy today, we're going to deliver a pizza. And to do so, we're going to need a few machines. So in our analogy, we're going to need a blender, an oven, and a car. And those are going to act as our functions in this analogy. So each of these is a machine that does things, takes things, does something to them, and returns something. All right. And then the other side is functions need data to run. So for our functions, we have a bunch of data already. These are ingredients you would need and tools you would need to deliver your pizza. Okay, so let's look at a very simple function. We're going to take a blender. Now we notice that all functions start with an equal sign. That tells the spreadsheet we're going to do something. And then you input the function name, in this case, blender, and I just used an image. And then we have parentheses, and those parentheses are like your container. So they take items in. For a blender, we take in any items, right? Anything you put in a blender, it's going to do its job. It's going to blend it up. So it can take one item, it can take 10 items. It doesn't matter the blender. So as we represent that in a function, those are arguments. And those arguments, to separate each of them, are separated by commas. That lets us know there are different items. And the parentheses let us know everything we're putting in. So if we look at this in our analogy, if we put tomato, garlic, and basil inside a blender, we see that those are three different things. What's it going to give us in return? We hit the button, it blends, and it will return tomato sauce. Okay, so very straightforward, fairly easy. Now, let's look at it a little bit different. What if we change the order? And then we put in basil, tomato, and garlic. Now, for this function, that doesn't matter. A blender doesn't care which order you put things in. All it does is its job of blending everything up and then returning it back, and again, as tomato sauce. Okay, good. So we know order in this kind of function doesn't matter. The amount of ingredients you put in doesn't matter. It's always going to do its job and return a result. Okay, now let's look at something slightly different. We're going to take the same function. We're even going to take the same number of arguments, but we're going to put in different data. So if we put in ice, pineapple, and some booze, we do not get back tomato sauce. This isn't broken. There's nothing wrong with this. This works, but it doesn't return what we want. Instead, it returns a daiquiri, right? Different thing, not necessarily what we want for making a pizza, though technically it's not broken. Okay, so how does this look in a real function? We have simple functions like sum, and sum says whatever is in the parentheses, I'm going to add it up and return something, and that number is 2 for this example. So 1, 1 returns 2. Now, how do we explain things a little bit further? We can see we have brackets in some explanations of what the arguments of function take, and that means that it's optional. Just like in a blender, we can put in multiple ingredients or just a few. Same thing with this, and it shows those to us as bracketed items. So if we see sum value 1, comma, bracket value 2, then we have ellipses. That means we can put in more arguments if we want, and they're optional. So for example, here, sum 2, 1, 20, 10 will return 33. And then we have some more examples. Sum 1 and 2 returns 3, so we only have 2 arguments. The next one, we have 4 arguments, and it returns 33. The next example, same four arguments in a different order, it still returns 33, right? We have some other functions that work just like this. Min and max, for example, do the same thing. Take whatever argument you give it, or any number of arguments, and we'll return something. So what max does is says, look through the list and show me the biggest one. So it doesn't matter how long or short the list is. Same with min, look through the list, show me the smallest one. Okay, so now in our spreadsheet, the cool thing about spreadsheets is you don't use up your data like you do in the real world. So in the real world, we may be out of tomatoes, garlic, and basil, but in a spreadsheet, you just keep adding data. So we have all of our base ingredients, plus now we have tomato sauce. And when we look at our data, we now have the ingredients we need to make a cheese pizza, because we have the cheese, we have the dough, and now we have the tomato sauce. So that means we're going to need another function to make our pizza, because you don't just stick together raw dough, cheese, and tomato sauce to make a pizza. You actually have to do something to it. So this comes in with our function that is the oven. So for this analogy, the oven will be our next function, but this one's different. So whereas the blender just took whatever you threw it and then spit something out, this one, you need to put things in the proper order. So we have a bottom item, a middle item, and a top item. In an oven, that matters. What you put on the bottom of the pan is important. So if we put in our correct data, because we know we need dough, cheese, and sauce, but we put it in the wrong order. We put the cheese on the bottom, and then we put sauce on top of it, and then we throw the dough on top of that. That's the right data, that's the right function, but that's the wrong order. And what do we get? Yes, we get an error. Our oven is on fire. You should not put cheese in the oven first. It'll hit the coils and burn, and it's bad. The same thing goes in our analogy for a function. If you put the wrong data in first, it will break. Okay, now similarly, if we put the wrong data in to our function, even if we put it in the proper order, which there really isn't order for a daiquiri, but if we put this data in, again, that's not going to give us the results we want. Again, we're going to get an oven on fire. Don't put booze in the oven. That's a bad idea. Okay, but take a step back. Now we've got the correct data with our dough, our sauce, and our cheese, and we put it in the oven. Dough first, sauce on that, cheese on top of that. Now we have the correct order, we have the correct data, we have the correct function, and we get a pizza. Okay, so this is how it looks in a spreadsheet. We have things like the function round, which says, give me a number and tell me how many decimal places you want, and I'm going to round that number. So our data is 31.366, and we say round it to 1 places. What that returns is 31.4. That's what we want. Now, if we flip this and said the value is 1, the places is 31.366, it is not going to give us the result we want, even though the data and the function are the functions we want. Okay, another one we have is COUNTIF. So we can see the function COUNTIF says look through a range and then count how many meet a criteria. So if we look here at the example, COUNTIF A1 through A5, we see, and then it says count our criteria is A2. So if we look at A2, it says Q, and then it says look through A1 through A5, so that's the entire column A, and how many Qs are there? It counts up 1. If we flip this, it would not be able to find that range within the criteria, and it would break. Okay, next up, sometimes we don't need full functions. Functions have a lot of built-in functionality to them. They have code written for them, and they're very useful, but we don't always have to use them. If we have our pizza and we have a box and we want to put our pizza in a box, we do not need a fancy function. We can just use a simple formula of add. So pizza plus box equals pizza in a box, right? No function needed. This is a really common issue I see with people as they're learning functions. If you've heard the saying, when you learn to use a hammer, everything looks like a nail, right? The same thing goes with functions. is when people who are new to spreadsheets learn them, they think everything must be a function and then it has to be really complicated. And that is just not always the case. Sometimes a simple solution is the best solution. So if you're finding you're struggling with something, think, is there a simpler way to do it? Okay, so now we have more data. We have pizza in a box. We got all the rest of our stuff. Last step, we need to deliver this guy. Okay, so again, we have brackets that mean optional, and some functions need to have a specific type of data, and they need to have it in the right order. In our oven, you could put in cheese, tomato, and dough. You could put them in separately if they were in containers, right? And it would still work because the oven's going to heat up everything. But not all functions are like that. Some functions, you have to have the right kind of data in the right place. So for our example, we have a car. The car has a fuel tank, which takes fuel, has a coolant reservoir, which takes coolant, and it has a trunk, which can hold items. Okay? Now, it needs each of those things in each of those places. If we decided not to put things in the trunk, that's fine, remember, because that had brackets, so that means it's optional. Nothing's broken with your car if the trunk is empty. No big deal. If the gas tank's empty, your car will not run. If the coolant reservoir is empty, it will not run for very long. Okay, so here we have a function where we put fuel in the tank, we put coolant in the reservoir, nothing in the trunk. This is not broken. This works just fine, but it doesn't get the result we want. So to get the result we want, we will need our extra data added in there. So if we do this, we'll drive around, we have no pizza, we cannot make our delivery. Now, up again, we can take different data and put it in different places, but that will not get us the result we want. So thinking about your car, if you put coolant in the fuel tank and gas in the coolant reservoir and pizza in the trunk, okay, we got the pizza right, but the other two are switched. So what does that mean? Well, if you think about this literally, that car's not going anywhere, and should you manage to get it started for even a second, having fuel in a coolant reservoir, bad news. This is an error. So we don't want to do this. We want to make sure that we have the correct type of data in the correct place. And again, if we use the wrong data, we have something flammable in the fuel tank, coolant in the reservoir, and pizza in the trunk. We're getting close, but this is the wrong kind of data. You do not want strong alcohol in an engine. That's bad news. Okay, so right kind of data in the right location gets us what we want. So now we have fuel in the tank, coolant in the coolant reservoir, and pizza in the trunk. We're good. And we can now deliver our pizza, and we have succeeded. So what does this look like in a real function? So we have a function called find, which says we want to look for something in some text, and we want to start at a specific number. Now notice the start is in brackets, which means we can ignore it, and the function will say start at the beginning. So I want to look for the letter A in banana, and I want to start at the 5th letter. And it says if you do that, it will be the 6th letter. Makes sense, right? So it's finding the first letter A starting at the 5th letter. So 1, 2, 3, 4, 5, start at that N. The next letter is an A, that is 6. Now if I switched any of these, search for 5 in A, start at banana, not going to work, okay? And if I put the wrong kind of information here, if I say search for a number, it's going to think it's text, not a number, right? So we have to have the correct term for each of these arguments in the correct order to get the result we want. Another one is VLOOKUP. This is my personal favorite function, and we're going to go in depth more with this function later in class. So it takes a key, a range, an index, and optionally whether it's sorted. So you can see here we have lots of different kinds of information. We have text, we have a reference to cells, we have a number that must be a specific kind of number, and we have a binary. So lots of different kinds of information in specific order to make it all work. Okay, now finally, sometimes functions can be within other functions. So let's look at this one and pause and think about this for just a moment. This should be fairly intuitive what's happening. Will this make a pizza for us? Yes, it will, because what happens is it's going to look at the inside arguments first. So it looks at the inside of these brackets and the inside of these brackets, and it says we have tomato, garlic, and basil inside this function of blender. That's going to return tomato sauce. So now it says we have dough on the bottom, tomato sauce in the middle, cheese on top. That goes into our oven, and that returns a pizza. So even though we see no tomato sauce here, this central argument, the function actually represents that return of sauce, so the whole thing will work. And we can keep building and layering on this for as far as we want, and the computer can understand it. Okay, so that ends this lecture. If you have questions, please feel free to reach out to me about these or get on our shared Discord.